General model of a compiler. When you are speaking about general model of a compiler, analysis and synthesis. The compiler design is divided into only two parts, analysis and synthesis. Analysis is nothing but the code, whatever is there, we are breaking down into components, we analyze them and follow a particular procedure accordingly based on the compiler. Synthesis, take all the components which has been break down, the code which has been break down, combine them and give a particular code which has to be given as a whole thing. That is what your assembly phase. So code is being combined. After this, code will be generated, optimized code and assembly code will be generated. So this is what synthesis, the combining all the breakdown components and performing, trying to get a desired output. That is synthesis phase. So this is what you have to write for general model of a compiler in the beginning. Then you have to start with phases of compiler. Which are the phases of compiler? How to write shortcut of phases of a compiler. So I just wanted you to remember, Lisa is very social. So you just note down, I have written Lisa in capital, SOC as capital. There are 7 phases, I need 7 letters. Now how I have trying to combine or convert this particular phrase into phases of a compiler. L, give space, I, space, S, space, A. Then insert each of the alphabet or character S, O, C. This will give you 7 phases of compiler. This has to be written for general model of a compiler. So after writing 2 parts of phases, then you have to write entire structure of a compiler. So here L, S, I, O, S, C, A. L stands for lexical phase, S stands for syntax phase, I stands for interpretation phase, O stands for optimization phase, S stands for storage, C stands for code generation phase, A stands for assembly phase. Please remember, when you are writing theory, always input is given to the lexical phase. So you are giving input to lexical phase. That is your source program. Then final output will be given by assembly phase. That will be your object or target program. Source program, object or target program will be given to you by assembly phase. Source program will be inputted to lexical phase. What is that lexical phase does? Lexical phase converts your source program into tokens. That is what lexical analysis phase does. What is syntax phase doing? Syntax and semantic phase uses reductions. Reductions are certain rules which has to be followed in your compiler phase. Interpretation. Interpretation will create parse tree and matrix will be generated by interpretation or intermediate phase. Optimization. The matrix which is being generated will be given as input to optimization phase. So optimized matrix will be generated. Optimized matrix will be generated by optimization phase. These tokens are divided into uniform symbol table, that is UST. So there are three classes of uniform symbol table: identifier, terminal and literal. Literal are numeric values in your program. Terminals are all the keywords which you have used, and symbols are terminals. Then what are identifiers? Any variable you have used in your program, including program name, are referred as identifiers. Then storage phase will allocate space for the variables. Allocating storage space for variables will be done by storage phase. Code generation, the matrix is being converted into code. Matrix is being converted into code. So under that we have code generation phase. Assembly phase, what code you are converting, that is assembly code will be converted. So assembly phase is responsible to convert assembly program to machine, that is zeros and ones. That is done by assembly phase. If you remember this, you can draw the structure of compiler very easily. What is that structure of a compiler does? Keep this in your memory. You have to write for general model from the beginning. From here you have to write what each phase does has to be written for general model. Whereas structure of a compiler, directly you can start with structure of a compiler. Structure of a compiler. So you have to remember same thing. Lisa is very social. How many phases you have? 7 phases. Draw 7 boxes. 1, 2, 3, 4, 5, 6, 7. So 7 boxes I have for structure of a compiler. General model of a compiler, you have to include this also. Keep this in your mind. Then whatever accordingly you have written: lexical phase, syntax phase, interpretation phase, optimization phase, storage assignment phase, code generation and assembly phase. Now please remember how to fill this. What is that you are inputting to lexical analysis phase? You are inputting source program. What is that we will get at the end from assembly phase? We will be getting object program. First fill like this: source program and object program. So this has to be given in box. Now what is that lexical phase does? It will create uniform symbol table. So that has to be, it has 3 things: identifier, literal and terminal. Please remember, terminals are symbols, are keywords. So directly it is being stored. So directly, which is being already followed, is being shown in dotted line. All dotted line is representing, it is standard, it is not differing for each program. Okay, it is being carried out by the compiler. It is being stored ready. So what is that lexical phase creating? It is creating uniform symbol table. Uniform symbol table consists of 3 things: identifier, terminals, literal. Terminals are keywords or symbols which are already stored. So lexical phase has to generate, based on the program, it has to generate 2 things, that is identifiers and literals, and it has to give the same to storage. All the identifiers, that is your variables, has to be stored in storage. Then syntax phase follows reductions. Reductions are certain rules which are standardized for a compiler. So using that, it will create a different syntax form. The code will be converted into appropriate syntax by following reductions. Then by taking uniform symbol table, it will be generating the reductions, and same symbols will be given to interpretation phase for generating matrix. What is being created in interpretation phase? Matrix. So I have given interpretation phase, parse tree, and parse tree is being converted into matrix. So matrix is being given as input to optimization phase. Optimization phase will give us optimized matrix. Optimized matrix is being provided by optimization phase. The same will be given to code generation phase. Code generation phase will create assembly code. Assembly code will be created by code generation phase, that is being given as input to assembly phase, which will give object program. When code generation phase is happening, you have something called code productions. So which are certain rules again which will be followed. So this will complete, and the identifiers, literals, has to be given to your code generation phase and assembly phase also for the necessary conversions. So this will complete your structure of a compiler. And you have to explain about each phase in the form of theory. So if you remember this, you can certainly write structure of a compiler, and this is exactly structure of a compiler. With theory you have to explain. Whenever you are drawing structure of a compiler, please use landscape of the answer sheet. Don't draw it like this because it is not sufficient. So make a note of this. You can take the same thing and explain it in theory. Convert into sentences, proper sentences. Before that, structure has to be written. If it is general model of a compiler, you have to start with two parts, that is analysis and synthesis. Then you have to explain them, then draw this diagram. That will complete general model of a compiler. For phases of a compiler also, you can write the same thing. Draw the diagram, explain phases of a compiler. But for passes of a compiler, it is little different. What is being done in passes of a compiler, the same structure of a compiler is being considered and converted into passes. What is that they have done? I'll show in next video.